Rainwater harvesting is a sustainable approach to water management that involves the collection, storage, and purification of rainwater collected from surfaces such as rooftops, parks, and roads for later use. This process is especially useful in areas with water scarcity and helps reduce dependence on traditional water sources. Let's explore the main components, benefits, and applications of rainwater harvesting systems. Components of rainwater harvesting systems. 1. Catchment, the area or surface that collects rainwater, such as rooftops, open fields, or paved surfaces. This is where the rain initially falls and gets captured for harvesting. 2. Conveyance system. This system of pipes or channels directs the collected rainwater from the catchment area to the storage area or recharge structure. The conveyance system ensures minimal loss and safe transportation of water. 3. First flush diverter. This component removes the initial flow of rainwater, which may contain dust, debris, and contaminants. By diverting this first flush, the system prevents pollutants from entering the storage tank. 4. Filter. The filtration system removes impurities, such as dirt, leaves, and other pollutants, from the water before it is stored. Common filters include sand filters, charcoal filters, and mesh filters. 5. Storage tanks and recharge structures. The filtered water is stored in tanks or directed to recharge structures that replenish groundwater levels. Storage tanks are made of materials like plastic, concrete, or metal and are often covered to prevent contamination and evaporation. Advantages of rainwater harvesting. 1. Reduces water bills. Using harvested rainwater for non-potable purposes like irrigation or cleaning can significantly lower household or business water bills. 2. Decreases demand on groundwater. By supplementing water supply with rainwater, communities reduce their reliance on groundwater sources, which helps prevent over-extraction and depletion of aquifers. 3. Provides alternative water supply during droughts. Rainwater harvesting systems offer an accessible water source during dry periods when traditional water supplies may be limited. 4. Reduces soil erosion and flooding. Collecting rainwater helps control surface runoff, reducing the risk of erosion and minimizing flood risks in urban and rural areas. 5. Improves groundwater levels. Through recharge systems, rainwater harvesting can help replenish groundwater aquifers. For example, in India, community-led rainwater harvesting projects involve recharging wells and aquifers, which have led to improved water levels in regions previously suffering from water scarcity. 6. Provides high-quality water for non-potable uses. Rainwater is naturally soft and free from harmful chemicals, making it ideal for certain uses without the need for significant treatment. For instance, rainwater is excellent for laundry, as it doesn't contain the minerals found in hard water that can cause fabric wear and mineral deposits. 7. Encourages sustainable water practices. Implementing rainwater harvesting encourages communities and individuals to think more sustainably about water usage. For example, schools that teach rainwater harvesting principles often have visible systems on site, which can foster a culture of water conservation among students and within the wider community. Disadvantages of rainwater harvesting. 1. High initial installation costs. Setting up a rainwater harvesting system, including purchasing tanks, filters, and pipes, can involve significant upfront expenses, especially for large systems. 2. Regular maintenance required. To ensure the water remains clean and the system functions efficiently, routine maintenance is necessary. This includes cleaning filters, removing debris, and inspecting tanks for any leaks or damage. 3. Limited storage capacity. Rainwater harvesting systems are often limited by the capacity of storage tanks, which may fill up quickly during heavy rainfall and leave no room for additional water. For example, a household with a small tank might find that it quickly overflows in rainy seasons, resulting in wasted water when they could use it later in drier months. 4. Dependence on rainfall patterns. Rainwater harvesting is directly dependent on local rainfall patterns, which can be unpredictable. For instance, in areas with irregular rainfall or dry seasons, a rainwater harvesting system may not provide a reliable water supply, leaving users without stored water when they need it most. 5. Potential for contamination. Without proper filtration and maintenance, rainwater can become contaminated with debris, bird droppings, or pollutants from rooftops. For example, in industrial areas, rainwater runoff from roofs can contain harmful chemicals that make the harvested water unsafe for use without extensive purification. 6. Space requirements. Large rainwater storage tanks or recharge pits require space, which can be challenging to find in dense urban areas or small properties. For instance, an apartment complex may not have sufficient space to install a community rainwater storage tank, limiting its ability to implement rainwater harvesting. 7. Possible algal growth and stagnation. Stored rainwater can become stagnant and lead to algal growth if not used frequently or maintained properly. For example, in rural areas with limited water usage, rainwater stored in tanks for long periods without circulation may develop algae, making it unsuitable for some applications without additional treatment. Applications of rainwater harvesting. Rainwater harvesting systems have a wide range of applications. Harvested rainwater can be used for 1. Irrigation, providing water for gardens, lawns, and agricultural fields. 2. Washing and cleaning, suitable for household cleaning, vehicle washing, and other non-potable uses. 3. Drinking water. With proper purification, rainwater can be made safe for drinking, especially in areas where potable water is scarce or of low quality. 4. Drinking water supply. With proper purification, rainwater can be made safe for drinking. For example, in remote Pacific islands where groundwater is limited, harvested rainwater is treated and used as the primary source of drinking water for communities. 5. Industrial cooling and processing. Industries often require large amounts of water for cooling and processing. Harvested rainwater can serve this purpose. For instance, some breweries in Europe use rainwater in their cooling systems, helping them conserve freshwater resources and reduce costs. 6. Groundwater recharge. Rainwater harvesting structures, such as recharge wells and percolation pits, are used to replenish groundwater levels. For example, urban areas in Chennai, India, have adopted recharge wells to direct rainwater back into aquifers, addressing water shortages by increasing groundwater levels. 7. Fire protection systems. In areas prone to fire, harvested rainwater can be stored for emergency firefighting purposes. For instance, some rural communities in California store rainwater in large tanks, providing a backup water source for firefighting during wildfire season.